For this lesson, we're going to start TrueGrid without an input file and go directly into the merge phase by typing merge. Now we're going to add a torus. Go to the surface menu and select SD for surface definition. Scroll down using your right mouse button and select torus. The torus dialog box will appear. A torus is defined by a local coordinate system. We have to specify what we want as the center. I'll use 0, 0, 0, and a vector that points in the direction of the center of the torus. In this case, I'm going to use 0, 0, 1. There are two radii. The first one is the big radius. Let's use 6. T1 indicates how far up this axis we go, and I'm going to use 0. The second radius is the cross-section of the torus, and it will be 1. We're going to use this torus to make a number of different curves. We have numerous curve types, but for most of them, you have to give the data one data at a time as a formatted command. These 4 curves are interactive, and they are generated by clicking the mouse, and that's what we're going to cover in this video. You will find all of the 3D curve commands in the 3D curve menu. The interactive curves are LP3, TWSURF, spline, and co-edge. Each of these have a unique way of creating a curve. We are going to start with a spline curve. We need to select points to create a spline curve. The spline curve is defined by a set of control points. In this example, we have 5 control points. The spline curve will pass through each of these points and do so smoothly. Each one of the points has an XYZ coordinate. Here's the formula for developing a smooth curve using those points. There are 6 extra constraints, 3 at this end and 3 at this end. There are 2 constraints each for the X, Y, and Z. You can specify the derivatives of the 2 end nodes of this spline curve. If you don't specify a derivative of the end constraints, it will use a default, and it usually defaults to something that works just fine. We're going to use the z-buffer to pick points in the physical window. The z-buffer function is only available when you are in the hide or the fill graphics mode. When I click my mouse on a spot on the surface of the torus, the z-buffer enters the coordinates of that point into the table of control points. I select another point on the torus, and now you can see a line connecting the 2 points. You have a line, not a curve, when you only have 2 points selected. As soon as you have a third point selected, you will get curvature. There are a number of things that you can do to adjust this curve, but notice that the last point that I have chosen has a little square around it. This signifies that the focus is currently on that control point, so it will be controlled by any point adjustments that I make. I can move the focus to a different control point by selecting a different point in the table. You can also delete a control point at any time by hitting delete once it's selected in the table. Every time I click the mouse, it adds a new control point. But if I turn off the insert mode, it will no longer add new points. It will only modify the existing points. In the environment window, I select Move Points and then Point List. We call this listing of control points our point list. Now I can use this group of Constrain To options to move the control points. For example, we can move this selected control point in the Y direction. Let's save this curve by clicking on Save, and let's give it a number. After saving, if you want to create another spline curve, you simply select Clear All, and you start to select your new curve control points in the physical window. Let's build an LP3 curve. You use an LP3 curve when you don't want a smooth curve, and you just want polygonal lines. The LP3 curve shares all of the editing and movement features that we just saw with the spline curve, so we won't review them again in detail. Number and save this curve. For the next curve, we need 2 surfaces, So we're going to add a cylinder that intersects the torus. We want the radius of the cylinder to be relatively small. I'll select Pick and then Z Buffer to use the Z Buffer to pick the center point of my cylinder. I want it big enough so that it intersects the torus in some areas, but not in all areas. I'm going to shift my radius over a little bit here. Because the Z buffer is on, the coordinates of the point that I just selected are saved in my buffer. Go to the Surface menu and select SD for the surface definition. This will be surface number 2. Select Cylinder. It's going to go through this point here, so that will be our point of axis of rotation. Use F8 to paste the point coordinates into the dialog box. We want the axes to be the z-axes, so enter 0, 0, 1 for the vector parallel to the axes of rotation. We want a relatively small cylinder, so let's use 0.5 for the radius. Now we have a cylinder that intersects the torus part of the way around. We are going to create a 3D curve that is the intersection of these two surfaces, and we're going to use the projection method to do that. TrueGrid finds the intersection by using the projection method. We need to choose a few points close to the intersection, just like we do when we build a mesh in the initialization step, to move the mesh close enough to the geometry so that the projection method knows what we're trying to do. In the Curve menu, we select TWSURF. Let's turn on Fill Graphics so that our two surfaces are displayed with different colors. We're going to use the Z buffer to select points that are close to the intersection of the two surfaces. You don't want to select too many control points, and you don't want the intervals to be more than 120 degrees, or the algorithm will have some difficulty. So we're going to select points every 90 to 60 degrees. Oh, but let's first clear all to remove the points from our last curve. Select 2 points on this side and then rotate it a little to get to the other side. Select several points here as well. Also, I'm using the Shift key as I rotate so that I can rotate with more accuracy. This doesn't need to be perfect, and it shouldn't take you a lot of time. After you have all of your points selected, click Prepend, followed by Accept. Based upon this initial shape, the TWSURF algorithm will refine it to result in a smooth curve. But we are going to need to give it a few more directions. We're going to tell it to intersect surface 1 and surface 2. Save the curve as curve number 3. Let's switch to wireframe graphics and close our points list box and examine the curve that was calculated. Now we can see the saddle-shaped curve that was formed at the intersection of these two surfaces. Next, we're going to create a curve along the surface by choosing the data points that define the surface of the torus. Let's zoom in. The surface is made up of numerous quadrilaterals that define the shape. By selecting the Surf Point option in the Labels menu, we can see the points on the surface of the torus. Notice, for example, on this contour of our surface, all of the points end with 31. The middle number is increasing, and its sequence makes up the complete 360 degrees of this torus in a set of 109. We see where 109 would rest is shared by 1 for the middle position. Why is this important? Because I may want to build a curve right off the contours of this surface. So I want to start my curve by selecting my first control point where the surface point middle index is 1, and I want to end it at 109. We are going to build this curve using the TRueGrid command. This will be our curve number 4, and select the option Begin with a Surface Contour. Instead of using the mouse to select the first point identifier, I'm going to type it in to be more exact. For the first point identifier, we use surface 1, index 1, and 16. For the last point identifier, we use surface 1, but for the index position, I'm going to pretend like I don't know that there are 109 points. and I'm going to substitute it for 0. And in this case, the command will find the last point for me. And lastly, 16. Now we have a new curve that runs all the way along the contour at 16. For a second example of the curve command, we are going to choose arbitrary points. Curve number 5, and select Begin with a surface contour again. Let's pick a point on the surface and hit F8 to paste that point into the dialog box, and repeat with a second point that you have selected from the surface. The algorithm will construct a curve on the shortest path between these 2 points on the surface of the torus. Let's turn off the labels and look at this in wireframe graphics mode. This is just a sampling of the 3D curve capabilities in TrueGrid. You can see from the menus that there are many more options. I encourage you to read the manual and experiment with the different options to become familiar with them.